Rock and roll.
Rock and roll.
All right, now, the lab. Okay, so the lab is a discovery lab or an inquiry lab tomorrow. What you're going to try to do is to find the delta HF naughts of a couple of metal ions. In other words, what I'm going to do is I'm going to give you a metal. You're going to react to produce the ion of that metal. And the way it's going to work is you're going to have the metal reacts with hydrochloric acid to produce the metal ion and hydrogen gas. All right? So what you can expect is something like this. The reaction is ridiculously simple. If you throw a metal into acid, you get hydrogen gas and ions. Pretty much guaranteed, unless it's like gold or silver, one of the royals that don't react. All right? Now, the HCl is going to sort of form your calorimeter. All right, it's a solution. This is aqueous. It's water, HCl in water, and it's going to form your calorimeter. Now, calorimeter. Basically, what your cup with water in it has served to be is a calorimeter for the first two experiments. All right? In reality, if you were testing, say, food, I've actually seen a bomb calorimeter that they use on food. They put the food in here. This is surrounded by lots and lots of water. They have some way of igniting it and knowing how much energy they put in to ignite it. They ignite your food and see how much energy it gives off. That's how they determine the calorie counts of foods. Okay? So it's not like they go and test it somehow. It's literally they actually burn it up and see how much food energy is. Hold on, yeah.
For everything?
Yeah.
So like Doritos, you know how you can like Doritos?
Oh, we'll play Does It Burn here in a minute.
Oh.
Burrito. All right, now, so here's the idea. One, we need to know, all right, the CP of this hydrochloric acid solution, okay? Because you've been using the CP of water and the mass of the water and the delta T of water to find the Q that was given off by, say, that piece of metal or given into the ice. In this case, the reaction is going to give the water energy. But it's not water, it's going to be hydrochloric acid. So we're going to need to know the CP of the hydrochloric acid solution in order to use that, the CP, the mass of the solution, and the delta T of the solution to figure out how much energy was given off by the reaction. Okay? Does that make sense? Okay. Now, cautions with this one, you will be using fairly strong acid, but the acid does not react with styrofoam, so you're fine there. So you can do the exact same methodology as you have in the past. Think about what the delta HF naught is for each of the things in here if you want to try to figure it out. All right, use your logic a little bit, and you'll find that it'll fall into place very nicely. Okay, any questions on the lab? The lab is now on Google Classroom available. I will attach this video to the assignment, and then you'll be able to access both directly. I'm like high tech and stuff. Yeah. All right. All right. Well, anybody questions, problems on the lab?
No.